Math lesson number 38. Graphing systems of linear equations. Let's start with the definition of the system of equations. So it is a set of two or more equations using the same variables. So for example, x plus y is equal to 5. That's the first equation. And then the second equation is 2x plus 3y is equal to 15. So this is what we call the system of equations. Now, the solution of an equation, of one equation only, is an ordered pair that satisfies the given equation. While the solution of, or the solution set of a system contains all ordered pairs that satisfy all the equations in the system. Check whether the given ordered pair is a solution to the system. So we're going to check if 3, 2 is a solution of x plus y equals 5 and 2x minus y equals 4. Now let's have the first equation, x plus y equals 5. We will substitute 3 to x and 2 to y. So 3 plus 2 equals 5. 5 is equal to 5, so which is true. Next, 2x minus y equals 4. We will substitute 3 to x and then 2 to y. So 2 times 3 minus 2 is equal to 4. 2 times 3 minus 2 is 4 is equal to 4, which is true. Therefore, this ordered pair 3, 2 is the solution or is a solution to the system x plus y equals 5 and 2x minus y equals 4. Let's have number 2. 3x plus 2y equals 11 and then x plus 5y equals 36. We're going to check if negative 1, 7 is a solution of this system. So first, we substitute negative 1 to x and then 7 to y. 3 times negative 1 plus 2 times 7 is equal to 11. 11 is equal to 11, which is true. Let's have the second equation, x plus 5y equals 36. Negative 1 is x and then 7 is y. So negative 1 minus 5 times 7 is equal to 36, but negative 1 minus 5 times 7 is 34. 34 is not equal to 36, so that is false. Therefore, negative 1, 7 is not a solution to the system. Now, there are ways to determine the solution set of a system. Some of the methods used are graphing, substitution, and elimination. Now, in solving system of equations, by graphing, we graph the two equations and determine the coordinates of the point of intersection of the two graphs. So let's have this example. Solve this system x plus y equals 4, 2x minus y equals 2 by graphing. So first step, we find the slope and y-intercept of the two equations. So first equation, x plus y equals 4, we will change this to slope-intercept form. Y is equal to negative x plus 4, wherein the slope here is negative 1. As you can see, negative 1, and then the y-intercept is 4. Now in the second equation, 2x minus y equals 2, we will change this to slope-intercept form. Y is equal to 2x minus 2, wherein the slope is 2 and y-intercept is negative 2. Step number 2, graph each equation using slope and y-intercept. Then locate the intersection of the two graphs. So in this case, this is the first equation, 2x minus y equals 2. And the second equation, x plus y equals 4. Now, as you can see, this is the intersection, 2, 2. The ordered pair of the point of intersection is the solution of the system. So in the given example, the graphs intersect at 2, 2. Therefore, the solution set of the system is 2, 2. So there's only one solution because there is only one intersection. Now, a system with at least one solution is called a consistent system. Again, a system with at least one solution is called a consistent system. Now, if the graphs of the system are two different lines, then the system is called independent system. Let's have number 2. Solve the system 6x minus 2y equals 4, y minus 3x equals negative 5 by graphing. First step, find the slope and y-intercept of the two equations for easy graphing. So 6x minus 2y, the first equation, equals 4. Change this to slope-intercept form. We have negative 2y equals negative 6x plus 4. So isolating negative 2y, and then we divide both sides by negative 2. As a result, we have y is equal to 3x minus 2. As you can see, the slope here is 3, and then the y-intercept is negative 2. So we'll be using that later to graph. Next, y minus 3x equals negative 5. So we'll change this to slope-intercept form. We transfer this negative 3x to the other side, so it will become positive. Now, as you can see, the slope is 3 and the y-intercept is negative 5. So we'll be using all this information to graph the two lines. Graph each equation using slope and y-intercept. Then locate the intersection of the two graphs. So as you can see, the first graph, 6x minus 2y equals 4, is this. And then the second graph, y is equal to 3x minus 5, is this. So as you can see, there is no intersection. Let's proceed to number 3. Step number 3. In the given example, the slopes are equal and the y-intercepts are different. Thus, the graphs are two parallel lines. Since they do not intersect, then the system has no solution. Take note. The two lines do not intersect. Therefore, the system has no solution. Or the solution set is an empty set. Now, a system with no solution is called an inconsistent system. Take note, if there's a solution, it is called consistent. If there's no solution, it is called inconsistent. Now, since the graphs are two different lines, then the system is an independent system. Let's have number 3. Solve the system 8x minus 4y equals 12, 4x minus 2y equals 6 by graphing. Now first, again, find the slope and y-intercept of the two equations for easy graphing. So 8x minus 4y equals 12, changing this to slope-intercept form. First, we isolate this negative 4y, and then we transfer 8x to the other side, so it will become negative 8x plus 12. Then we divide all sides by negative 4. As a result, we have y is equal to 2x minus 3, wherein the slope is 2 and y-intercept is negative 3. Next equation, 4x minus 2y equals 6. Negative 2y is equal to negative 4x plus 6. Then we divide all sides by negative 2. We have y is equal to 2x minus 3. And then the slope is 2 and y-intercept is negative 3. So as you notice, the slopes are equal, 2 and 2, and the y-intercepts are also equal, negative 3 and negative 3. So let's see what will happen. Graph each equation using slope and y-intercept and locate the intersection of the two graphs. So as you can see, this is 4x minus 2y equals 6. So the graphs are overlapping. So the graphs are also coinciding. Get the coordinates of the point of intersection of the two graphs. In the given example, the two graphs coincide, and thus the given system has infinite number of solutions. A system with infinite solutions is called a consistent system. So because there is a solution, so it is also considered as a consistent system. Now, since the graphs of the equations are the same, then the system is called dependent system. Take note, if the graphs are two different lines, the graphs are called independent system. Now, if the graphs of the equations are the same, then the system is called dependent. Now, let's have the summary. A system of equations is a set of two or more equations using the same variables. So, if you use x and y in the first equation, you must use x and y also in the second equation. Now, the solution set of a system contains all ordered pairs that satisfy all the equations in the system. Those ordered pairs must satisfy the first equation, the second equation, and so on and so forth. Consistent system is a system having one or more solutions. Inconsistent is a system having no solution. Independent system is a system whose graphs are different lines. Dependent system is a system whose graphs are coinciding or same line.